in the crossfire.
This is a Samsung SyncMaster F2380 23-inch computer monitor. This thing dates from about 2010 and it's a PVA monitor and probably one of the last new CCFL backlit monitors to hit the market. This particular one seems to have led a rather rough life and it's got an ABB logo stamped to the front, so this has probably been used as some sort of industrial automation type display device, meaning it's probably got about 1 million display hours behind it. So I haven't powered this on yet. I have no idea what's wrong with it, if anything, but regardless of what happens, we're going to take it apart because I'm really curious to see what's inside such a high-end monitor. They retailed for over $300 back then, and supposedly they have very good picture quality, perhaps even by today's standards, depending on how worn out the backlight is. And probably the power supply since Samsung's of this era, bad caps. So let's just jump straight to the point and give it some power. 230 volts coming from there, power on back there. Let's give it some juice. And it did charge the primary side cap. It was drawing a pulse of power. Now the power button seems to be doing nothing. None of the buttons do anything. So it seems to be entirely dead. Although we do know we have a good primary side circuit, since it draw a peak of power, meaning that it did charge the primary side cap. So fuse is good, power switch is on. We have some internal faults. So let's get this thing apart and see what happens. Oh, and we're also probably not dealing with an inverter fault since it's not turning on at all. If this were an inverter fault, we would probably hear it starting, see some distorted image or reddish image, and it would just hiss at us and die afterwards. So I'm thinking probably bad capacitors, logic supply. That's my bet. So let's get inside and see if that's true. Bit of a beauty cover here, open there it says, and it just snaps it off, making horrible noises. There we go, one of these horrible forks, base and mains where they've just replaced a couple of the screws with a couple of latches, just in order to make sure you cannot reuse the main for anything else if a monitor fails, rendering it rather useless, but you can always grind these off, drill a couple of holes and reuse it anyway. So we have got a rather different design than usual on these. The back plate here seems to be snapped into the front bezel, so we're going to have to attack this from behind, which is a good thing because it's going to leave less visible marks on the monitor. Let's see where we can work our way inside. Finally inside. So it's a pretty typical layout. OSD there, nice big shielding plate for the CCFL wiring there. Going to the inverter board, and if we have a look inside there, I can't see any obvious issues, but we're going to take this whole assembly out and see what we have. So CCFLs come out like so. This weird metal thing isn't attached to anything. Piece of tape over the LVDS cable comes off, LVDS cable comes out, control panel cable comes out, and this unit is liberated. I am suspecting logic caps, and whoa, that's run hard and we've got bad caps. No one's surprised. Let's replace these guys. Actually decently rated Samyang ones. Surprised to see these fail, but these diodes have run so hot Jeez, that is not good. I think we're doing that horrible thing. Yes, we are. Where we're just running a bunch of diodes in parallel with no equalization at all. This is a bad design and very common in modern devices. Alright, and there we have our reworked board. So thus far the repair has taken just under half an hour, including my rambling and the installation of some rather silly looking heatsinks on both the output diodes via the switching power supply and the inverter driver which resides underneath there. So this is actually keeping up with being a reasonably economic repair, even if this were to be done by a professional shop for a customer. So it's time we get that power supply back into the monitor and seeing if it powers up. I am hoping we don't have CCFL trouble, because if we do, this thing is RIP. Alright, I've got it put back together. It's just lying flat down on its face, so there's nothing to see except for the power it draws. So we're looking for a difference in the behaviour. Previously it charged the primary cap and then did nothing. If it's fixed, then it's going to do the same thing, sit for a bit, and then start drawing more power as it hums back to life. So let's flip the switch and see what happens. Now we have the charging with primary cap, and it's humming to life, drawing 34 watts. And I do think this is going to be a fix. Let's flip it on its back and see if we get image. Alright, here comes the moment of truth. Power. We have no signal connected though, but it should light up. Oh yeah, it's light up. Searching for signal and not going to find any. Let's give it some and see if we're going to get proper image and if it's going to be all horribly red tinted and ruined as it all too often is on high hour CCFL backlit displays. And there we go. We have got a Cosmic Anna on our panel and it's not looking entirely horrible even. Let's have a look in the menu, see if perhaps this guy has got an hour cone to outside of the service menu. I'm thinking probably not. Holy crap, has this thing got hours? 66,635. That's ridiculous. Now, I'm a bit confused because I do think the venerable old 225W and its friends used to give you a separate power on and panel hour count, because 66,635 hours on the panel does sound like too much. I would have expected a more serious failure at that point, so I think that might be the time it's been sitting plugged into the wall. But then again, industrial service this thing's probably been through. Could be that's actual panel hours. Now the panel does have a rather low light output. It's not very bright, even on 100% brightness, despite drawing quite a bit of power. So maybe. I don't think we're going to actually get an answer to that. So there we go. That's a fixed Samsung F2380 monitor with 66,000 hours on it, and as such it's so dark and dim that it's entirely outclassed by a not very bright laptop monitor. Still, we have saved it from the scrap heap for another while at least. It's certainly got some left to give, but the brightness of this panel really is pathetically low. It's probably under 100 candela per square meter. It's certainly nowhere near the 248 that this thing did out of a box. So yeah, not really a victory, but hey, it works. It's got 2 DVIs. I'm sure it'll find a use somewhere. So thank you for watching, and I hope you enjoy yourself. Alright, hang on to your hats, I just couldn't resist just slapping the Spider 4 on this thing. And it is incredibly dark. In fact, the brightness level measures at 50 candela per square meter. That is ridiculous. That's like... I haven't seen a monitor that dark in quite some time. The good thing though is it actually can hit a decent 6500K white point if you crank the colors to something ridiculous. Those are the color settings we're using to achieve 6500K white. So the way these CTFLs work is the older they get, the less blue they get. So you can quickly just gauge how worn out one is by seeing how much blue you need to achieve a certain color temperature. And this thing, perhaps it's got those 66,000 hours, because that is a lot of blue and very little light. And there we have a report on it after fiddling around a bit. So this performance is really rather not good in any way, shape or form. Same for the actually decent over 1000:1 contrast ratio, but it can just barely push over 2 in gamma if we just crank the contrast and set it to the highest gamma setting, and the color temperature's just drifted off of 6500K again. So yeah, this thing is never going to be accurate again unless those backlight tubes are replaced, and that's not happening. So decent black levels though, gotta give it that. But something I have noticed to make it even a bit more insulting, we have a dead pixel, which is entirely out of focus because it's so dark. There we go. A dead pixel stuck on white in the top corner of a display. This thing is not in good shape, but still, it works, I guess. In the crossfire.